Hey there, everyone. In today's teaching lesson, I want to discuss the difference between bias and variance, okay? And of course, we use Python to do the analysis. This is a Jupyter notebook. I'm going to share all the code. When I post the video, I'm going to save this file as an HTML file. You can download the file, double-click it to open it, and you'll have all the code exactly like you see here, so you don't have to retype everything, and you don't have to understand all the details of everything that's going on as we go through it. You can take your time when you have some free time and just do this at your own leisure. So I think sharing the code and letting people interact with this and learn just by hands-on interaction, I think is the best way to learn. It's certainly more effective than learning just by watching the video and seeing what's going on. That's very passive. I think any kind of active learning experience is going to be much more productive. So what is bias? Basically, it's the difference between a predicted value and an expected value. So you have a certain expectation or preconceived notion of what something should be, but the predicted value could be different from that, right? It's not always going to meet your expectations. That's the bias. This is the inability of the ML algo to understand the real relationships between the data variables, right? Like the model could overlearn or underlearn, and both are sort of dangerous positions to be in. You want the model to learn accurately and be able to generalize from the data points it's seen onto unseen data points and make predictions on unseen data points. If it makes a prediction on the data point it's already seen, it's just memorized something and it's just regurgitating exactly what it's seen, right? You want to be able to actually learn, and to do that, the model has to be able to generalize. Now, variance is when the model takes into account the fluctuations of the data, including the noise. So variance could be just as dangerous as bias. Bias is you think something's going to happen, but it's not going to happen. Variance is when there's too much noise in the data that doesn't really matter, but the computer is picking it up and thinks that that's important, right? So we want to try to avoid both types of scenarios. So you want to try to be in between both. You're always going to have some bias or some variance, but you want to trade off some for the other, but not take on too much of one or the other, okay? So the split should be between some bias and some variance, but we want to try to minimize both, okay? So I think the chart here illustrates that. Here's a small mathematical formula to illustrate the point of how basically the math works here, okay? So let me go ahead and run a linear regression model on this mtcars data set. If you see my other videos, I use this a lot. I like it. I think it's pretty flexible. It's great for illustrating a lot of these scenarios that we see in the ML world and the data science field. And it's overall very complete. There's no missing data points. It's pretty intuitive. Horsepower, cylinders, displacement of the car. Normally, my Y variable is miles per gallon. If you've seen that in other videos, you'll see this repeating type of setup over and over. It doesn't have to be MPG. It can be any one of these variables. Whatever independent variables you pick, you're saying that it's going to have an influence on the dependent variable. So here the X is the independent and the Y is the dependent. Okay, we're going to train, test, and split the data. The test size is going to be 0.33, so the training size is going to be 0.66, okay, or 0.67, okay? So if you see my other videos, I tell you all about that and get into it. So here we're going to run the first example here. I'm going to click Control-Enter to run the cell, and normally in most of my videos I'm looking at mean square error, that's MSE, root mean square error, or R squared, or sometimes R squared, adjusted R squared. That's actually better than R squared. But in this case, we're going to look at just a couple of these variables, plus the bias and the variance. So here we say the mean square error is 358.36. The bias is 22.15. That means the miles per gallon on average is going to be about, I think it's 22. The bias here is pretty high, so 22. So it could predict pretty accurately, but could be off by a huge margin. And the average variance here is 336. So that's a pretty big number here. Let me go down a little bit. I have some notes here. If you compare the overall mean square error, 358, the bias is relatively small. Okay, so 22 out of the 358 is pretty small. And the bias, it's about 6% of the mean square error. So it's relatively small, but still 22 is kind of big, and the average variance is kind of big. So what can we do to try to reduce the bias and the variance in these examples. There's a few techniques we can employ. A lasso regression might help us do the trick. So Lasso helps the model to prevent overfitting, right? That's when you start to learn the noise of the data, and you don't want to learn the noise. You want to learn the nuances, but not the incorrect patterns of the data. If there's something that's kind of weird in the data, the model should be smart enough to just ignore that as noise and say, okay, it's not really relevant. It doesn't really matter. So Lasso and ridge regression is another way to reduce overfitting potential outcomes of models. And in one of my videos, I've tried this a few times. Lasso and ridge regression didn't really work too well for me, and I kind of like just kicked it to the side and I said it's not super relevant. It really depends on the scenario. In some cases, it's not going to make any difference at all. In some cases, it actually does improve the learning capability of the model. In this case, the Lasso regression actually helped us go from a bias of 22.15 down to 20.19, so there's a slight improvement there. But the average variance was improved very significantly. It went from 336 down to 1.9. So in this case, Lasso regression, I didn't run a ridge regression, I don't think. You can just rerun this and import ridge and test that. I didn't do it, but that's fine. We got one of the two. And look at the improvement there. It's huge, right? So we went from 22.15 to 20. That's a slight improvement. And 336 to 1.9. That's a massive improvement. So Lasso really came through huge in this experiment. And these are called experiments because you don't know what the outcome is going to be, right? You have to run different scenarios and see what happens. Only then are you going to know, is the model performing well? Is it not performing well? Can you change the hyperparameters? Can you add tuning? Can you make the random forest model learn deeper? Can you change the epochs in TensorFlow and PyTorch and help those models to learn better? So there's a bunch of different things you can help to improve the learning outcome of these models. Okay, so that was a regression experiment. Let's look at a classification. On the other side of the coin here, we have classification. A lot of problems if they're continuous or numerical, they're regression. If you're dealing with the labels, this is going to be a classifying type of problem. Great idea or great example of a classifier would be large, medium, small, extra large, extra small, things like that. Those are labels. They describe the size of a shirt, probably, maybe the size of pants if it's just general. So a label would be more of a named assignment or a named label, and the regression problem would be more numeric and more data is continuous. Okay, so I think I just ran it. Let me refresh it just to make sure. Okay, data accuracy is 1.0, so pretty accurate, even more accurate than what we saw above here. 1.0, and then the higher the better, right? 0.99 is good, 0.98 is good, 1.0 is basically perfect. And the data accuracy is 0.94. Again, closer to 1.0 is good, so we're looking pretty decent here. We are going to do some basic pruning here and then run a decision tree classifier model. Okay, so Control Enter to run it. We're looking at the average expected loss, bias variance, and the Scikit-learn. So Scikit-learn has a whole bunch of these models. I think they're up to about 120 or 130. They cover all kinds of regression, classification, clustering. So it's really a nice library, all open source, all free. So here the average bias is 0.053, very low. So that's desirable, and average variance is 0.024. So this is pretty much the holy grail here. Average expected loss is pretty low. All these numbers look fantastic. The bias and variance you want to be low. The accuracy, the recall, the precision you want to be high, right? So this is looking really good now. Let's look at another example here. This is a k-neighbor classifier. Some of these models have both classification and regression. So random forest is a classifier and a regressor. K-neighbors is a classifier and a regressor. There's a few that have both sides, right? So let me go ahead and hit Control Enter to refresh this, and we'll check out the results. Okay, so again, bias variance, low numbers, looking super good. I'm very thrilled with these outcomes, looking great here. This is a KNN classifier, and then again, bias variance decomposition. Let's run this, see what the outcome is. Okay, Control Enter runs it. Bias 0.05, variance 0.024, loss So, okay, this is running iterations, okay, because we're going from 1 to 21, so we're going to get 21 iterations and see if the model can actually make improvements as it iterates through all these models. It's trying to learn better and more from the previous example. Okay, let's see if we can achieve that goal. So I'm seeing numbers that are, seems like it's kind of improving, but just slightly. Maybe, I take it back. Maybe it's not improving. Maybe it's not improving. After 21 iterations, we'll have our final results. Let me see the hourglass at the top left stop then. And this is done, 0.025, 0.0234. Yeah, so the learning improved at the beginning, and I think it's kind of plateaued, and it's not improving anymore. Yeah, it's not improving. That's fine. So we tried it. It worked at the beginning, and then it got to sort of a stopping point where it kept running iterations, but it wasn't learning any new information or improving the predictive capabilities of the model. But that's fine, right? We achieved the mission. We got a low bias, low variance, and tried a couple different scenarios, and the outcome was auspicious here. So I'm pretty happy with the results. So that's it, guys. That's bias and variance in a nutshell. I'm going to save the code and post it with the video. Go ahead and download this HTML file. You can double click it to open it. You'll have access to all the source code, just like you see here. You can run it on your own Jupyter Notebook environment and test it, learn from it, and hopefully you'll finish with this experiment with having gained some new knowledge. Hopefully I dropped some knowledge here that is going to help you learning in your data science career and machine learning chosen career fields here. Okay, thanks for your time today, everybody. Have a great day. Bye.